Hello everyone, welcome back to my channel. This is Dahul. Today we are tackling an exciting coding problem, Minimize XOR. It's a fun mix of bit manipulation and optimization, and I will walk you through everything step by step. Let's get started. So, here is the problem. It's simple yet interesting. We have two positive integers, num1 and num2. Our goal is to find a positive integer x such that x has the same number of set bits once binary as num2 and the value of x XOR num1 is minimized. Let's understand this better using one example. So if you say this, here num1 is 3 and num2 is 5. When it comes to binary, for num3 it is 0011 and for 5 it is 0101. Num2 has two set bits, that is ones, so we need to construct a number x with exactly two set bits. The challenge is to choose x such that the XOR of x and num1 is as small as possible. The output for this example is 3 because 3 in binary terms it is 0011 has two set bits just like num2. The XOR of 3 XOR 3 is 0 which is minimal. I hope you understand. So let's jump into the code. First of all, we need to initialize one variable in order to count the set bits in num2. So int num2. I will use the inbuilt function integer dot bit count of num2. Then I have to initialize another variable to store the result. So I will name it as result only. We will do it in two steps. First of all, we have to set bits in num1 in order from most significant to least significant. For that, we will use one for loop for int I equal to 31, I greater than equal to 0, and set bits num2 greater than 0 and decrement I. Then we have to check if the ith bit of num1 is set. So we have to put the condition if num1 ampersand 1 when I not equal to 0. If it is, then we have to set the ith bit of the result or equal to I, and we have to decrease the number of required set bits minus minus. So we done our first step. Second, we need to add any remaining set bits from the least significant bit. So same, we will write one loop I equal to 0, I less than equal to 31, and set bits num2 greater than 0, then increment I. Now we have to check if the ith bit is not already set. If it is like this, then set the ith bit of result. Then we have to decrease the number of required set bits. That's it. Now we have to return the result. Let's run it. But okay, by mistake. Yeah, it's working. So I will just show you again what I did. So here first we count the set bits once in nums2 using Java's inbuilt method. That's the integer.bitCount. For our example, num2 is 5, which are two set bits. Then next we try to construct our result text by copying set bits from num1 in order of significance. So this ensures that x is as close as possible to num1, minimizing the XOR difference. In this loop, we check each bit of num1 starting from the most significant bit, that's the bit 31, to the least significant bit, that's bit 0. If a bit is set in num1 and we still need more set bits, we copy that bit into x. Then after that, we are what we are doing here is we just add remaining set bits. After the first loop, if there are set bits left to add, we start from the least significant. That's why we start from 0. Then we goes to the higher significant and add and set bits to x. This ensure we only add bits where necessary, further minimizing the XOR difference. Finally, we return the x as the result. In our example, when we mention about this, it is 3, which have exactly 2 set bits and minimizes the XOR difference with num1. So submit it. Yeah, you can see it's fully efficient. The time complexity of this solution is big of 32. Since we iterate over at most 32 bits, the space complexity is big of 1 as no extra data structures are used. This makes our solution both efficient and elegant. And that's how you solve the minimize XOR problem. If you enjoyed this explanation, don't forget to like, subscribe, and share. Let me know in comments if you have any question or suggestion for future videos. Thanks for watching, and I will see you in the next one.